Hello, people, and welcome, and thank you for joining us on today's session, where we're going to talk with Gustavo Romero Sanchez. Gustavo is a seasoned principal DevOps engineer with a specialized focus on Amazon Web Services, Microsoft Azure Cloud, and security compliance, honed over a span of 12 years. So you know that he's an expert in this talk. Today, he's going to be talking to us about AI augmented cloud insights for everyone. But before we go to that, we want to remind you to follow us on our social media so you can see next talks over there, and to leave your comments and questions in chat so we can see those at the end of the talk. Without further ado, Gustavo, the floor is all yours.
Thank you so much. Okay, let's begin with our presentation today. Let me just quickly share my screen. All right, so today we're gonna talk about AI augmented cloud insights for everyone. And this is what our agenda looks like today. First, we're gonna give a little bit of introduction to the topic. We're gonna talk about observability and monitoring, the cloud, and generative AI. Then we're gonna talk about our proof of value that we created, what are the components for our proof of value, and then we're gonna move on onto the demo, showing what we have done to display this. And after that, we'll go over some of the components, how is everything working under the hood. And finally, we'll talk about some final summary and recommended next steps. So let's get into it. As we know, there's a huge rise of cloud adoption everywhere. As we can see in the numbers here, 92% of organizations have a multi-cloud setup today, and 31% of organizations are spending at least $200 million per year on the public cloud. So we can safely say that cloud adoption is on the rise. Obviously, the cloud comes with the opportunity to produce new products, experiences, and all the operational efficiencies that come with that at a large scale. But there's always a catch. Since we have all these new components, there are a lot more data to handle at a greater speed. And we also have multiple sources, multiple formats of data that is being generated from multiple services and applications that we have in the cloud. This comes with an increased complexity for monitoring and observability practices, which in turn takes a lot of engineering time for all of our operational teams. But it is not all bad news. We have an exciting opportunity. As of today, as we all know, we have reached an inflection point because all generative AI and large language models are providing solutions that we never thought were possible before. Just some numbers that we have come across: 98% of global executives agree that AI foundation models will play an important role in their organization's strategies in the next 3 to 5 years. There's an estimate of 40% of engineering working hours that any given developer can be impacted by large language models like GPT-4. And we have a 63% of categories that will be impacted by large language models that will range from low end at 9% up to 62% at the high end for everyday work. So obviously we have a very exciting landscape right now to create new applications, and this is the correct time to take the opportunity to create new applications that can transform the way we do things. So with this said, we'll pass on to the proof of value components that we created. This is all based on a hypothesis. We wanted to make sure if GPT-4 can instantaneously provide insights from an AWS account using natural language queries. Basically, we want to acquire key insights, which would normally require creating code or third-party tooling. This is to say, maybe I want to know, I want to have an inventory from my AWS resources, or maybe I want to do a security scan for compliance in my application that is running in AWS. But all of this will probably take some time. So what we want to do with this is leveraging GPT-4, being able to get insights instantaneously via chat, and additionally provide actionable items for specific given insights. And we also want the solution architecture to be portable so that it can be used with any AWS account. So these are the components that we selected for proof of value. The first thing, obviously, an AWS account, which will host all the serverless components for the solution itself, and obviously for all the querying that we want to do. This is where we're going to get all the info required to generate the insights. We're going to leverage Azure OpenAI service, specifically using the GPT-4 model. Azure's OpenAI service comes with a lot of models that are readily available, GPT 3.5 and many others. This can also be done using OpenAI's own cloud service. The Azure version is pretty much the same. It just has additional controls specifically done for enterprise applications. So this is a good choice for us. The third component is a SteamPipe IO, which is a powerful open source solution that allows you to query cloud services using SQL. So this service on its own allows you to query services like AWS, Azure, Google Cloud, and many other popular software as a service solutions that are used by us on an everyday. And the interesting part is that this is all using SQL. Just to give you an overview of how AWS works with SteamPipe, it has 400 tables in its schema that you can query, and it interacts directly with the AWS API. So this tool on its own works great, but it's SQL based. So we're gonna improve that. The fourth key component is a LangChain Python library. This is a framework for developing applications specifically by large language models. And as you have probably seen and probably played around with ChatGPT, you can do many interesting things, but you're limited to the amount of data you can copy paste into the chat, or the limit of tokens that you may have. So LangChain, what it does is gives you an edge, and lets you interconnect data sources, so your application is actually data aware. So you can actually interact with different data sources and make use GPT-4 power with data awareness. So it's the glue between GPT-4 and all the components that we're using here. Secondary components, we're using Slack, which is a popular chat service. This is what we're going to use as our interface to interact with our proof of value. And finally, the serverless framework. We use this solution for defining all the components as an infrastructure as code package that can be reused between different AWS accounts. So what does our architecture look like? Here we're gonna simulate how the solution works end to end. So as an end user, we're gonna interact with the Slack via a Slack application and a Slack bot, Slack app, and we're gonna write queries in natural language. For example, I'm gonna ask about users, existing users in the AWS account, S3 buckets, Lambda functions. And once this is received, this will go inside AWS through the API gateway, and we'll have the first Lambda function, which will be a handler for Slack. And this Lambda function interacts with our main Lambda function, which is our ChatGPT PostgreSQL handler. So this is where we have the interaction set up with LangChain and SteamPipe and the OpenAI service, Azure OpenAI service, and the AWS API. So once we have received a query, what will happen first is that we'll throw that same query in natural language and throw it into the Azure OpenAI service. The Azure OpenAI service will interpret this query and turn it into a executable PostgreSQL query, and this will return again to the Lambda function and then go to the SteamPipe solution, which is actually it interacts as a PostgreSQL DB. It doesn't have any live data underneath. What it does is it will consult with the AWS API, but obviously since it uses Postgres underneath, it receives SQL queries that are formatted as Postgres queries. So once we launch this query, the SteamPipe component will return the query result in a raw format. So we'll throw that raw result into GPT-4 once again, and GPT-4 will do the summarization analysis for us, and then return a human readable result back to the user. So we'll go back to the end user via the Slack application, and we'll receive our results. So this is how it works. Obviously, all of this, like we said, is deployed using the serverless framework, and this is our entire solution. So now we're gonna go and actually take a look at our AWS Insights tool in Slack. Allow me to reshare my screen real quickly now. Okay, so we're gonna start doing some basic querying here. For example, I'm gonna ask about give me a list of Lambda functions in the AWS account. So while we're doing this, obviously, as you would expect, this takes a few seconds because we're opening a few connections to SteamPipe, and SteamPipe in turn is opening some querying to the AWS API. And if you have played with GPT-4, you know, especially GPT-4 is kind of slow. So we are bound by the velocity of that. So, well, gladly, it didn't take too long, and we can see we got the result. So we have a list of Lambda functions that are AWS Insights Project ChatGPT, AWS Insights Project Slack, and Slackbot. So those are the 3 Lambda functions that I have in my AWS account. Okay, so that's cool. Let's do something different. We'll ask about existing users. And we'll ask for the creation date. Say I want to inventory the existing users in the AWS account and when were they created. So yeah, this is going to take a few seconds because we're doing the SQL query, and this has to be interpreted. The raw output, we need to first create a SQL query, then the output needs to be formatted, so it takes a few seconds. So we have received the existing AWS users right now, and we have, for example, 3 users. We have a user named Slack, and when this was created, all using UTC time zone. This is interesting, but let's try something a little bit more complex. So, for example, I'm gonna ask about a security compliance. Here in this query, I'm asking to do an assessment of all existing Lambda functions and their applicable AWS CIS benchmark controls. When we're gonna ask GPT-4 to list the findings and some recommended actions. So yeah, this was pretty good. Now this obviously what comes into play here is the Lambda warm up. Now that we have been executing this a few times, Lambda is warm, and so we're getting faster results. So we asked about CIS compliance. As we can see, there are 3 Lambda functions. This we already knew, and now this time is looking also for the runtime that each of the Lambda functions are using, and whether BPCs, any of these Lambda functions are attached to a BPC. So the recommending actions is, it says for all Lambda functions, ensure they're using latest runtime, CIS 4.1. In this case, all functions except Slackbot are using the latest Python runtime, 3.9. Update the Slackbot function to use the Python 3.9. So yeah, this is a valid observation. As we can see, this Lambda function is actually using an outdated runtime. So in order to comply with the CIS 4.1 control, we would need to update these functions runtime. The second observation is for Lambda functions that require access to resource within a BPC, ensure they are attached to a BPC. In this case, none of the Lambda functions are attached to a BPC. So yeah, in this case, it requires, in order to comply to CIS 4.2, we would need all of these Lambda functions to be attached to a VPC, because they're interacting with components inside a VPC. So we are not compliant, and these are the recommended actions. So this is pretty interesting. Let's try a different compliance program. In this case, we can now ask about HIPAA compliance, which is related to the health industry in the US. So we'll ask about our S3 buckets and see how we're doing there. So as we can see, so far, we are able to leverage GPT-4 to do some key insights and actually provide recommended actions as well. So yeah, this was also pretty fast, at least based on my experience. What it says is, based on the query results, some S3 buckets are not compliant with the HIPAA policies. Here are the findings and possible corrective actions. So there are 3 buckets that have versioning disabled. We have to enable versioning on these buckets to make them compliant. And we have server-side encryption enabled for all the buckets, which is compliant with HIPAA. No corrective action is needed for encryption. So this is very interesting. As we know, there are several AWS services that are already HIPAA compliant, but there's also some controls that still fall under the end user to applicate in your particular workloads. In this case, for example, bucket versioning, right? And different encryption services might also affect our compliance. So so far we have a very interesting return for our queries, and we are validating that this just works. So now, what is happening under the hood? As we have shown, this happens very fast. But basically, what happens is, when we submit a request about an AWS account in natural language, then LangChain will open a connection to SteamPipe to get awareness of the schema. This is an important part. So queries can be created, and they can be queries that actually make sense, right? Without awareness of the schema, GPT-4 on its own will not be able to produce syntactically correct queries. After that, we're using a pre-trained prompt that will be used to generate a SQL statement. We'll look in a minute what that pre-trained prompt looks like. And after that, the SQL statement is executed against the database, and results are yielded. The results are sent to Azure OpenAI GPT-4 for interpretation and summarization of the findings based on the prompt. And the interpreted results are returned to the end user. So this is, as we can see here, a LangChain is connecting everything that we have: prompts, large language models, chains. Right now, we're not using agents. This is just an illustrative image, but this is also a possibility for interactions, specific interactions with chatbots. And obviously, document loaders and utilizations, and this can be anything, right? This can be, in our case, it's the database, the Postgres, the SteamPipe Postgres database, but LangChain can also interact with PDFs and code repositories, and many other things. So this is how it all comes together. We are forming a chain of different components to do powerful applications, AI-powered applications. So now looking at the main LangChain handler code, basically we're importing some of the LangChain libraries, specifically those related to SQL and large language models. The first thing we're gonna do is set up a database connection, and this is assuming that you have your steam pipe Postgres database exposed. This can be locally or can be through a cloud instance. The only thing that matters is that it needs to be reachable by where this code is running. And then we set up our large language model. In this case, as we're using Azure OpenAI service, it varies. We're opening a connection to this. We have to select the deployment name we use in Azure. You're using GPT-4, and we're selecting the temperature level of 0 because we want to make sure our results are correct, as correct as possible. We don't need much creativity for this use case, but yeah, this is where the interesting part comes. We're using a fine-tuned prompt. So as you can see here, even when LangChain has all the preloaded schema and the tables and all that information, it will still make mistakes. GPT-4 will actually make the mistakes. So in this case, we follow a good practice of prompt engineering, which is create a fine-tuned prompt. So this is a fine-tuned prompt that we created based on our interactions. And actually, when using LangChain, I have two options, right? When I want to query a specific table, I know my application is going to query specific tables from a given schema. Then what I can do to give additional context to GPT-4 is to preload tables. But this comes at a cost, right? If I preload a table that is too big, that has too many columns, I will obviously incur in additional costs. As we all know, GPT-4 costs are based on tokens, right? So the longer context I will send, the more expensive my query will be. So a good practice for this is actually just give it some hints, right? So this is the process of fine-tuning. So instead of preloading tables, what I'm doing here is I'm just giving it a few hints. Where should it look for specific queries? What column should it use for a specific encryption? And as you can see, all of this is done via natural language as well. So this is actually an iterative process. While you're developing, you will sometimes end up with a very large prompt, but in practice, this will save you a lot of not only costs, but it will give you exact results. This is what we found here. And finally, we set up the database chain using all of the components that we declared before, and we launch the question, right, and wait for an answer. This is how easy it is to create. I'm going to show, before we move on into the next steps, I'm going to show a little bit of the debug mode, so you guys can have an idea of how the debug mode works. Just give me 1 second. So when you're running on debug mode locally, you're able to see what is happening when you do a query. So here we're gonna ask the same question about S3 buckets and HIPAA policies. So as we can see, the first thing that it did is it's loading the fine-tuned prompt, and then it generated the SQL query, right? So this is a good interaction that is good for debugging when queries are failing repeatedly. Even when you give specific hints, you may still get failed results. So in this case, we can see what is the query that was generated and the raw result. And yeah, this is the summarized answer and the actual chain that was returned. So yeah, this is very, very important. The only thing you need to do to set up this debug mode is set up verbosity to true and have something code like this to be able to query constantly for debugging and this process of prompt engineering. So some of the lessons we learned by doing a proof of value is that, as we said, you can leverage LangChain features such as agents that we didn't show today. And one specific feature that you can also use is preloading specific tables and rows to give more context to GPT-4. Another thing that we can do is, this is a general best practice from prompt engineering, using prompt fine-tuning, which is basically giving hints to your prompt so you can get a better result. And as we had said, for debugging mode, you can turn on the verbose mode. So some summary and results, as we can see, large language models are transforming cloud operation and the software development lifecycle by making it more inclusive, more intuitive, and more self-operational. You can, a proof of value like this can be used by anyone without any tech concept, even probably without any real AWS background. It's extremely easy to use and very easy to build as well. And we also have some interesting metrics that we have come from our own Encora generative AI technology practice. We have estimated that up to 75% we can save in time for setting up a cloud and monitoring and observability suite from scratch using a similar approach to what we have shown today. We can also use this to do root cause analysis, which can give us up to 90% of time reduction. And obviously, as we have seen in this demo, when we need to create cloud security and compliance reports, we can save up to 50% of the time that this would typically take without a tool like this. So next steps, any potential additional use cases for our proof of value today, we can easily add Azure and Google Cloud capabilities, and we can add actions. This is to say, not only give a response, a text response, but also give you the option to do changes on the fly. From the chat, you can actually make the changes and make it more flexible for any user. So, are you now ready to kickstart your journey with AI augmented cloud insights? That is a question for you. And that is all I have for today.
Wow. Thank you so much, Gustavo, for the great presentation that you gave to us and all the knowledge that you shared today. Just as a reminder for everyone, remember to return to the official website so you can watch the next talks from there. You can access them over there. And also to follow us in our social media so you're up to date with all of the things that we have for you. And with that being said, thank you, Gustavo. Thank you, all of you, and see you next time.